So in this tutorial we're going to have a look at component interfaces inside Creo, and we're going to work through this PDF tutorial. I'll put a link to the download below this video, but essentially component interfaces allow you to pre-specify certain component faces or edges or points or even datum features, so that when you bring those components into an assembly and you're looking to set up the assembly constraints, it becomes easier because you've already pre-picked some references on the components themselves to create those constraints from. So we'll drop into this first section of the tutorial, which is basically looking at this screw model or bolt model, as it's called in there. And basically what we're going to do is we're going to tell the system that when this bolt comes into an assembly, it invariably needs to be placed inside a hole feature, and we want the underside of the head of the bolt here to be coincident with a face in the assembly. So what we tell the system is use the cylindrical face here as one component interface, and use the underside of the head there as the second component interface. And in this particular example we're going to tell it we want both of those constraints to be coincident constraints. So that's what we're going to set up. So if I just open the bolt up, so there's the bolt. I've already set my working directory to the correct subfolder for this particular tutorial. So there's the bolt model, and before we get going, there's a couple of tree filters or settings that you need to ensure that you've got switched on. Again, this is all outlined in the PDF. So if we go to tree filters, you want to ensure you've got the placement folder active and the annotations active. And the features, you should already have that one active. So features, annotations and placement folder all active. And then what we're going to do is we're going to create the component interface. So you can see we're just in the normal modeling tab, and the component interface is on the far right hand side of the ribbon. So if we click on the component interface, and the type of component interface that we're going to create here is called a placing component interface. And what that means is the component interface is on the part which is being brought in to an assembly to be placed within the assembly. The other type of component interface that we're going to look at a little bit later is called a receiving component interface, and you tend to put those on components that are already in the assembly and have had their position locked down already, but that when you bring other components in, you want those other components to be able to place themselves on that initial component somehow. So yeah, it's going to be a placing interface. So we're going to give it a specific name. This one, we're going to call it, in this particular example, we're going to call it an insert mate. We're going to change the type of it from either to placing. I've already said that. And then what we're going to do is we're going to populate this list on the left hand side here with the reference surfaces, in this case from our model. So the first one that we're going to pick is this cylindrical face. You can see the cylindrical face is split into two equal halves. That's just the way that the 3D modeling kernel handles cylinders or cylindrical faces. So either one of those two halves is fine. So we'll click on that. You can see it's entered that surface into the list here, and it's picked what it considers to be the most logical constraint type for the item that we've clicked on, and it's picked coincident there, which in this instance is what we want. But you can see that we've got all our constraint types that you'd expect to find when you were bringing a component into an assembly. So we'll leave that on coincident, and automatically the next face that I click on will be entered into this list as a second reference. So I'm going to click on the underside of the bolt head there, and again it's picked a constraint type to apply to that surface. So you can see there, surface 5, which is this surface that I've just clicked on, it's chosen coincident again. So it's chosen the correct option there, but just be aware that you can change that. So if you wanted these bolts to be slightly offset from the top surface of your larger component, you could set a distance mate in there if you wanted. So yeah, we've set up that component interface, so I'm just going to OK that. And then what you can see in the feature tree here is that at the bottom of the feature tree, because we switched on that tree filter option that was for the placement folder, we've got a little feature there called footer. And what we're going to do is we're going to browse all the way down inside this and see what sort of features are contained within this. And you can see there's our component interface that we named as insert mate. So that was the name that we gave it. And within there, there's two features. There's a coincident component interface reference for the cylindrical face, and there's a coincident component interface reference for the underside of the head there. So that's how you would get in there and possibly edit these things if you needed to edit them. You could go back in and you can see we're back in the same menu again. We could change these around, or we could change them to a different type of constraint, but that's how you access them again. So what we're going to do next is we're just going to pull up an assembly, and we're going to start bringing these bolt components into that assembly and seeing how the component interface that we've just set up speeds up the placement of components in an assembly. So I'm going to load that assembly in. So there's the assembly file again. It's in the tutorials subfolder that is specific to this bit of the tutorial, the interface placing subfolder. So I'll load that assembly up. There's the larger assembly. You can see it's just a really simple block with some drilled holes in it. And the expectation is in this particular assembly that when we bring those bolt models in, we're going to want to constrain them so that the cylindrical face on the bolt is coincident with these cylindrical faces in the holes, and the underside of the head of the bolt is coincident with this planar face on the top of this component. So normally what you do is you click on assemble, you bring your bolt in here, and you'd have to click on a surface on the bolt and then a surface in the model in order to get that constraint set up. But you can see the system has already pre-selected the surface on the bolt that it expects you're going to want to use, and it's getting that information out of the component interface that we have already set up. So basically you get rid of half of the number of mouse clicks that you would need to do if you were placing this component and it didn't have a component interface set up. So all I have to do is select the references from the base component, let's call it, this block component. So I select the inside of one of these holes, and then what the system's done is it's pre-selected the underside of the head of the bolt, so I just have to click on the top surface, and there's the bolt placed, fully constrained. So we'll just do that 3 more times, and I recommend you do the same just to get the feel for how this works. So inside of the hole, top surface, fully constrained. Assemble, another copy, inside of the hole, top surface of the block, fully constrained. One last time, inside of the hole and top surface of the block, and it's fully constrained. So yeah, it's essentially a labour saving tool, component interfaces, to minimize the number of clicks that you have to perform when you're performing placing tasks or constraining tasks within an assembly. So in this next section we're going to have a look at creating a receiving component interface. So in this case we've got a fairly similar drilled block that we're then going to place some bolts in, and the bolt model that we're going to use in this particular tutorial has already had a component interface saved inside it. So the bolt model has that component interface already. In the course of this bit of the tutorial we're going to create a component interface on the block itself as well. So that almost fully automates the assembly process. So you'll see that when we've set both of these component interfaces up and we bring the bolt in, it's a much simpler operation to fully constrain that bolt than it would be if there were no component interfaces involved at all. So again, it's about automating that repetitive constraining task when you bring components such as a bolt into an assembly. So yeah, again, there's a specific folder within the tutorial zip file. There's the folder reference. So I've set my working directory to that folder. So I'm just going to open up the block itself. So if you put the preview on down there, you can see the components that you're about to open. So there's the block. And again, if you've just jumped into this video and you haven't done the first section that we've just completed, you want to make sure that your tree filters or your model tree items have features selected and placement folder and annotations as well. So what are we going to do first? We're going to do largely the same setup steps that we did in the bolt when we were making the placing component reference. So we're going to click on the component reference button. We're going to name this component reference. It recommends that you name it, give it a specific name. We're going to call it insert mate hex. You can give it whatever name makes sense to you. We're going to change it to a receiving component interface, because you could regard this as the static component in the assembly. This is the component that's likely to be inserted first in the assembly. So that it's this component that needs the receiving end of the component interface. So we'll change this to receiving. You'll get a warning because you can't set receiving as the default. It's just saying interface will no longer be default. Yep, that's fine. And then what we're going to do, we're going to pick one of these holes. So we're going to pick this one at the bottom left, and we're going to set our component interface to reference the inside cylindrical surface of the hole. So that's the first one. It picks a default constraint type that it thinks is most sensible for that. You could change that if you needed to. As it happens, we want the coincident constraint type. And then the second component interface reference that we're going to pick is the top surface. So again, it's chosen coincident. That happens to be the type of constraint that we want, so we'll just leave that. And then we'll click on OK. Now what you can do now is you can shut this model down, because that model will stay resident in memory even when you close the modeling window down. I'm just going to leave that open in the background. It doesn't really make any difference. You could do this either way. You can close it and do the next step, or leave it open in the background. So I'm now going to open the assembly that contains this block. So there's the assembly. It just has the block in at this point in time. So here's the assembly with the block already in it. And if we have a look inside the actual block component and make sure that we have the annotations option selected in our display tree filters, you can see there's a pattern at the bottom of the feature tree there, and if we browse inside that, there's our component interface that we named insert mate hex. So you can see that's been patterned to match the hole pattern inside the block itself. So now what we're going to do is we're going to bring in our bolt component. So this is the bolt that is in this particular working directory, the interface receiving one. And as I've already said, this bolt has had its own placing component interface already set up. So just like we did on the other tutorial, this has had a component interface set up which references this cylindrical face and the underside of the head itself as well. So the combination of using a component interface on the component which is being placed and on the component which is receiving that first component leads to this situation where we can just click on these diamond icons, and wherever we click, a copy of this bolt will be placed. So we'll try that. So we'll click on this diamond here, you can see the bolt appears, and then we can click on any other one of these patterned locations, and the bolt simply places itself automatically. So it uses the component interfaces stored within the bolt itself and the component interfaces that we set up on the actual block component. So there's a little bit of extra flexibility that's been saved inside this bolt, and that is that it's had two component interfaces saved within the bolt model. So if we go and have a little look around and see how this bolt model has been set up, you can see we're down inside the bolt model here, we're browsing inside the component interfaces, and you can see it's got two separate component interfaces set up. So if we browse inside these, they're very similar to the bolt component interface that we set up, except that one of them has a distance constraint rather than a coincident constraint. So one of them is called insert mate and the other one is called insert mate offset. And what that means is, as we come to place a copy of this bolt into this assembly now, so let's place one here, we'll just click. We've got two options in this drop down box. So we can use this component interface that's been set up inside the bolt, or we can use this one. And if we click on that one, you can see that the bolt is now offset by a certain number of millimeters away from the top surface of the block. So you can do that. You can store multiple component interfaces inside either a placing component interface, or inside a receiving component interface. So every time we place one of these, from now on, it will follow that setting. So we'll place another one there until we turn it back to the other component interface, and then it will follow that setting. So again, it massively simplifies the process of constraining these products or these components inside an assembly. This procedure, given that we've got 8 bolts here, would take a lot longer if neither of these two components had any component interfaces set up at all. So it automates the process of assembling components within Creo. So we'll just have a little check to see that we've covered everything in that section in the tutorial. So yeah, we set up the component interface on the block, we brought some bolts in, we investigated the fact that the bolts themselves have two different component interfaces saved within them, one that has an offset and one that's got a coincident constraint, and then we completed it. So yeah, that's the conclusion of this part of the component interfaces tutorial. We're going to move on to this next section next. So yeah, if you want to get that loaded up yourselves, we'll move on to that shortly. So in this next section, we're going to set up a placing component interface again, just like we did in the first tutorial. Only in this setup, rather than working on the component part and then making the changes to it, what we're going to do is we're going to bring the component part in. We're going to use the standard method of constraining it in the assembly. So that would be the manual method of setting up an assembly. So that's not using component interfaces. And when we fully constrain this component in this hole here, there's an option to save out its constraints as a new component interface. So we achieve exactly the same thing that we did in the first tutorial. We create a placing component interface within a part which is destined to be placed in a larger assembly, but rather than doing it within the part itself, we essentially take a copy of an assembly constraint. So let's do that now. So yeah, you're going to want to set your working directory to the correct directory again that's outlined in the PDF. And what we're going to do is just load the block within the assembly. So we're going to load this assembly part up. The assembly currently just has the block, so it's been named as save as interface or save as INTF. And this has no component interfaces set up at all. So as I said, we're just going to place the first component that we bring in just using standard assembly constraining techniques, no component interfaces at all. So we're going to go assemble, we're going to bring this component in, so it's this cap. So if we open that up, and then because we haven't set up any component interfaces, as I've already said, we're going to have to select a reference on the component, select a reference on this component. You can see the system's picked coincident as the default constraint, and if we drag that upwards so we can just see the underside of the head, and then the next two references that we want to constrain relative to each other are the underside of the head of that component and the top surface of the block. And we actually want these two coincident as well. So this distance constraint that's been selected by the system, I'm going to double click on that and change that to a coincident as well. So now that component has been fully constrained. You can see that on the status bar at the top there. So I'm going to click on OK. And then if I go back into that component and just go into the placement folder, check that that's worked, which I think it has. Yep, we've got our two coincident constraints in there. And then what I'm going to do is I'm going to edit the definition. So I'm going to get back into my component placement toolbar here. And when that's active, if you slow right click on a piece of free space on the screen, you get this pop-up menu displayed, and right at the bottom of the pop-up menu there, there's a save as interface option. So I'm going to click on that. I'm going to give this component interface a name. So we're going to name it whatever the tutorial tells us to. Where is it? Insert mate, I think, is the name that they recommend. But really, any name that you find convenient would be okay. So we'll click on OK, and then we'll OK that menu as well. So what we've done there is we've saved a component interface inside this component, but we've achieved that by doing it on the fly. So we've not at any point loaded this component up in its own window and created the component interface the way that we did in the first tutorial. We've just saved out some assembly constraints that we happen to have set up as a new component interface. And we can check that that's been achieved by If we browse inside that component in the assembly tree here, and then we look down at the bottom there in the footer folder into interfaces, and there it is. That was the name that we gave that component interface. So it has actually been saved. And then if we browse right to the bottom level of that set of folders, you can see the two bits of geometry that have been referenced are that cylindrical face there, and the underside, that planar face or flat face on the underside of the head. So that's just another way to achieve setting up of component interfaces, but doing it on the fly, so taking your reference from an already constrained component within an assembly. And then again, we'll just check that that has actually worked by, if we assemble another copy of this cap component, we should just have to select one side of the constraints there. So we select the cylindrical face on the block and the top face of the block, and it has actually used the component interfaces that we saved inside the cap. So we didn't have to select any references on the cap itself, they were already set up. So that seems to have worked. So that's the end of the tutorial on component interfaces, and in summary, it's essentially a work saving tool, the component interface, that if you have a component like a bolt or some sort of equivalent component like that, that you may be placing lots of copies of in an assembly, it allows you to essentially pre-select the references on that component that will always be used when that component is constrained within an assembly. So yeah, it's a labour saving tool essentially.